So at this point, let's move on to some examples to see how this process works. We've got our first example here. We want to graph the following quadratic function using the described steps above. So the quadratic we have to work with is y equals -1/2 times x plus 2 squared minus 1. Now again, we know that we always start with finding the vertex. Now what's nice is that since we are in vertex form, again reminding us of that, that's y equals a times x minus h squared plus k. Okay, we're in that form, our a being the -1/2, our h being, in this case, believe it or not, -2, because I'd have to plug a -2 in for h for the minus negative to give me the positive that I have right here. And last but not least, k is -1. So again, the tricky piece here is to understand that the h value is actually the opposite of whatever sign is in front of that h. So in our case, our h value is equal to -2, and our k value is equal to -1. This gives us the vertex coordinate point of -2, -1. Okay? Reminding us that h is the x coordinate and k is the y coordinate of our vertex. So we have our vertex now, -2, -1. So I'm going to graph that. -2, -1 is the point right here. So we have our vertex now. Step 2 said, once we have our vertex, we want to build a t-table around our vertex. So to do that, I'm going to construct my xy t-table here. And in the middle of my t-table is where I'm going to put my vertex of -2, -1. Now again, because we want to see both sides of our parabola, I want to pick x values on either side of my vertex. So -2, I'm going to pick -1 and 0 as x values on one side of my vertex, and -3, -4 on the other side of my vertex. This will give me points to plot on my coordinate plane on both sides of my vertex so that I can see both sides operating on my graph. So what we want to do at this point is we want to plug the x values that we've chosen into our function and solve. Now just to keep myself straight, I like to put a dashed line right here so that I can do the work to the right of that line and then record the result in the y column. So here's how I'm going to approach this. We're first going to start with the x value of 0. I need to plug 0 into my function above and solve for y. So plugging in 0 for x, that gives me -1/2 times 0 plus 2 squared minus 1. -1/2 times 0 plus 2 squared minus 1. And what does this equal? Well, let's bring up our calculator. Okay. And here's how I'm going to enter it into my calculator. I'm going to enter -1 divided by 2 in parentheses, multiplied by 0 plus 2, close parenthesis, squared. So that's -1/2 times 0 plus 2 squared minus 1. Hit enter, and that produces a value of -3. So when I plug in 0, it gives me a value of -3. Okay. Now we need to plug in the value of -1. Okay, plugging in the value of -1 produces -1/2 times -1 plus 2 squared minus 1. This was -3. So now we have a -1 in the location of our x instead of a 0. So again, we're working on -1 here. Bringing our calculator back. How am I going to enter this in? I'm going to enter it in as -1, divided by 2 in parentheses times -1 plus 2, and that is squared, and then from that minus 1. And when I hit enter, I get negative 1.5. So this is equal to negative 1.5. So when I plug in -1, I get negative 1.5, 1.5. Now we could continue this for the -3 and the -4, but because we know that parabolas are symmetric, we can figure out the values of the -3 and the -4 based off of symmetry. Because -1 is 1 unit away from our vertex at -2, and -3 here is also 1 unit away, we know that by symmetry, if I plug -3 in, I should get the same value as if I plug -1 in. So because of symmetry, I know that if I plug in -3, I end up with negative 1.5. The same argument can be made with the 0 and the -4. Each of these values are 2 units away from your vertex of -2, the x-coordinate of your vertex -2. Therefore, their y values should also be the same. So because we got -3 when we plug 0 in, when we plug -4 in, we're also going to get -3. So you can even see the symmetry in our y column right here, because parabolas exhibit symmetry around the vertex. So now we have several points that we can plot on our graph. 0, -3 is this point here. We now have -1, -1.5. We already have our -2, -1 plotted. We have -3, -1.5. And lastly, we have -4, -3. Those points line up nicely in the shape of what we expect, a parabola. So what we can now do is connect these dots in the shape of a parabola to finish our graph. And there we go. There's the parabola, the shape or the graph of our function y equals -1/2 times x plus 2 squared minus 1. Now there were a few things that we needed to do on the graph to communicate that we know where certain pieces are. The first thing is we needed to label the vertex, which was at -2, -1. I then get to pick any 2 other points to label as well. I'm going to pick this point right here, which is at 0, -3. And I'm also going to pick the point right above it, which is -1, -1.5. So I've got my vertex and 2 other points labeled. What I want to do next is draw and then label my axis of symmetry. We know the axis of symmetry goes right through the vertex and splits our parabola in half. Now a vertical line crosses through the x-axis. Therefore, the equation of a vertical line is x equals wherever it crosses through the x-axis. Crosses through the x-axis at -2 for us, so the equation of our axis of symmetry is x equals -2. We now have our parabola completed, the graph of our quadratic completed, with the vertex, 2 other points labeled, our axis of symmetry drawn and labeled.